The radius of a planet is twice the radius of Earth. Both have almost equal average mass densities. Vp and Ve are escape velocities of planet and Earth respectively. Then our aim is to find out what about the relation between them. So we are comparing a planet and Earth. So in the first part it is given that the radius of planet is twice the radius of Earth. So if you are assuming that radius of Earth is r, then the radius of planet is nothing but we can take it as 2r. Both have almost equal mass densities, so density of Earth and density of that planet is same. And our aim is to find out the relation between their escape velocity. So escape velocity of planet is given as nothing but Vp, on that Earth it is given as nothing but Ve. So we know the equation for escape velocity, that is escape velocity is under root of 2gm divided by the value of radius r. Now we are going to write the value of this escape velocity in terms of given parameters like radius, density. So we can write this as 2 into g into this mass of an object can be written as nothing but density into volume divided by radius r. So we can write escape velocity is under root of 2 into g into rho into the value of volume of spherical shape object can be written as 4 by 3 pi r cube divided by r over here. So we can cancel this r and r over here, so it is going to be nothing but r square. So escape velocity is under root of 2 into g into rho into 4 pi r square divided by 3. Now we can say that as the escape velocity is directly proportional to root of r square, we can take it as r, and the other parameters are constant. So we can say that the escape velocity of that planet divided by escape velocity of Earth is equal to radius of that planet divided by radius of Earth. And according to the question, it is given that if we are considering radius of Earth as r, then radius of that planet is 2r. So we can cancel this r. So we'll get the relation between them, that is velocity, escape velocity on that planet is 2 times of escape velocity on Earth.